Hello student, welcome to my next lecture on chapter number 4, that is atomic structure. In this point I will discuss the point number 4.7, that is quantum mechanical model of atom. Okay, in a new branch of science called quantum mechanics was developed by 1926 in 1926, that is Werner Heisenberg and Erwin Schrödinger, based on uncertainty principles and wave motion respectively. Quantum mechanics based on the ideas of wave motion will be discussed here. Schrödinger developed the fundamental equation of quantum mechanics, which incorporate wave principle, wave particles, duality of matter. The Schrödinger equation or wave equation is written as H into psi is equal to E into psi. Here H is a mechanical operator called Hamilton and psi is the wave function and E is the total energy of the system. Solving Schrödinger equation is beyond the scope of this book. It may, however, not be noted that solution of Schrödinger equation gives E into E and psi. Okay, next. 4.7.1, that is Schrödinger wave equation. When Schrödinger equation is solved for hydrogen atoms, the possible value of energy E that the electron may have along with the corresponding wave function psi are obtained as a neutral consequences of solving this equation. Natural consequences, that is natural consequences of solving this equation. A set of three quantum numbers characteristic of this quantized energy level and the corresponding wave functions are obtained. These are principal quantum number n, azimuthal quantum number l and the magnetic quantum number ml. यहाँ पे l small होता है. The solution of Schrödinger wave equation lead to three quantum numbers and successfully predicted feature of hydrogen atom emission spectrum. Splitting of spectral line in multi-electron atom emission spectra could not be explained through such a model. Okay, only hydrogens like species will be explain this equation. These were explained by Jar Unhelingbeck and Samuel Goldsmith in 1925, who proposed the presence of the fourth quantum number called electron spin quantum number, that is represented by ms. Wave function psi as such does not have any physical meaning. इसका कुछ meaning है नहीं, ऐसा एक symbol दिया है. The probability of finding an electron at a point which an atom is proportional to psi square in the neighborhood of that point within a tiny volume of element. around it. Next point, atomic orbitals and quantum numbers. Many wave functions are possible for an electron, and therefore many atomic orbitals in an atom. Thus, the wave function or atomic orbitals form the basis of the quantum mechanical electronic structure of an atom. Then the various orbitals in an atom differ in size and shape and orientation with respect to the nucleus, depending upon the values of psi square. Each, each orbital is designated by three quantum number labeled as n, l, and ml. That is principal quantum number, azimuthal quantum number, and magnetic quantum number, and each electron being assigned with four quantum numbers wise: principal quantum number n, azimuthal quantum number l, and magnetic quantum number ml, and spin quantum number ms. The principal quantum number n is a positive integer with values of n being 1, 2, 3, 4, etc. It identifies the shell, the atomic orbitals having the same value of n belong to the same shell. You have to memorize atomic orbitals having this, when n value is same, then it is belong the same shell. Okay. With increase of n, with the increase of n, the number of allowed orbitals in that shell increases and given by n square. A set of orbitals with given values of n constitute a single shell. Shells are represented by a symbols of k, l, m, n, and so on. The next table 4.6 shows n an electronic shell of its symbol. The atomic orbitals and quantum numbers continue this point. What is the allowed orbitals in first four shell? In this table, you have to simply observe what is the principal quantum number start from 1, 2, 3, 4. Shell is indicated by k, l, m, n, and allow number of orbitals in n square, that is 1, 4, 9, and 16 orbitals. Size of shell is from top to bottom increases, and number of electrons present in twice n square is also increases, that is 2, 8, 18, and 32. Okay. With an increase of n, the distance from the nucleus and size of the shell increases. Simply, with an increase, n is increased, the distance from nucleus and size of the shell also increases, and energy also increases, becoming lesser and lesser from negative. In hydrogen-like species, the energy of orbital depends only on the value of n. In the case of multi-electron atoms, the energy of orbitals depend on two quantum number, that is principal quantum number and azimuthal quantum number n and l as well. Next. the azimuthal quantum number small l. The azimuthal quantum number L, small l, is also called subsidiary quantum number. Atomic orbitals with the same value. In this azimuthal quantum number, what we explain, that is the atomic orbital with the same value. Atomic orbital means same value of n but different value of l constitute a subshell belong to the shell for a given n. Then the number of subshell in a shell is equal to n. Thus, the third shell contains 3 subshells with 3 different values of L. The second shell contains 2 subshells and the first shell contains only 1 subshell. The values of L range from 0 to n minus 1. Thus, the K shell with n is equal to 1 contains only 1 subshell having L is equal to 0. The subshell or sublevels have L values will be start from 0, 1, 2, 3, etc., which are represented by the symbols S, P, D, F respectively. The next point, that is the magnetic orbitals quantum number. The magnetic orbitals quantum number ML gives information about the relative spatial orientation of the orbitals in a given subshell. For any subshell defined by L value, it gives twice L plus 1 values from ML are possible, which range through ML is equal to minus 1 in bracket L minus 1 minus in bracket L minus 2 that 0, then plus L minus 2 plus L minus 1 into L, etc. Thus, for the subshell S with L is equal to 0, then only one allowed values, the only allowed values of ML is equal to 0. In other words, a subshell has only one orbital in it. A subshell में खाली एक ही ऑर्बिटल्स होता है. For the subshell P having L is equal to V1, then the allowed values of MLs are minus 1, 0 and plus 1. Thus, P subshell contains 3 orbitals having distinct orientation and so on. The sum of orbitals in a constituent subshell gives the total number of orbitals in a constant shell and is given by n square as shown in table number 4.7. Distribution of orbitals in shell and subshell are simply observed in this table. First point, that is shell is represented by K, L, M. Then what is the principal quantum number is equal to n is equal to 1, 2 and 3. Total number of orbitals n square, you have to simply calculate, that is n square, 1 square is equal to 1, 2 square is equal to 4 and 3 square is equal to 9. Total number of subshell is indicate only 1, 2 and 3. Then the azimuthal quantum number is equal to L is equal to n minus 1, simple L is equal to 0 in case of shell. Then p subshell, that is L is equal to 0, 1. Then 3 is total number of n is equal to 3, then L is equal to 0, 1 and 2. The number of orbitals in the subshell twice L plus 1 is equal to 1, 2 into 0 plus 1 is equal to 1, 2 into 0 plus 1 is equal to 1, and then 2 into 1 plus 1 is equal to 3. 2 into जैसे आपको वन सीक्वेंस में आपको कैलकुलेशन करना है. तो टोटल नंबर ऑफ सबशेल you have to count, that is first k is equal to 1, L is equal to 4 and M is equal to 9. Okay, next one, the electron spin quantum number. Electron spin quantum number ms specifies the spin state of the electron in an orbital. An electron spin around its axis. This imparts spin angular momentum to the electron. The two orientation which the spin angular momentum of an electron can take of give rise to the spin state, which can be distributed from each other by the spin quantum number ms, which can be represented either plus 1/2 or minus 1/2. The two spin states are represented by two arrows. One is pointing up and second is pointing down, and thus have opposite spin, which is known as opposite spin. Lastly, an orbital can accommodate maximum 2 electrons, and they must have opposite spin. This is known as Pauli's exclusive principle.